Welcome to the fascinating world of Russian multiplication, a mathematical method that unravels the complexity of multiplication through a simple yet systematic approach. In this video, we'll embark on an exploration of Russian multiplication, its problem, strategy, algorithm, code implementation, and time complexity analysis. Problem. Russian multiplication, also known as the ancient Egyptian multiplication or peasant multiplication, dates back to ancient times. It was devised as an ingenious method to multiply two numbers by using halving, doubling, and addition. At its essence, Russian multiplication thrives on the principle of breaking down multiplication into a series of halving one number while doubling the other and then summing the doubled values corresponding to the halved numbers. Now, we want to calculate 17 by 26. Actually, it might seem difficult. But we have a simple solution. So, the Russian multiplication strategy employs a systematic doubling in halving approach to efficiently multiply numbers by adding corresponding values while one number is halved and the other is doubled, simplifying complex multiplications into smaller, manageable steps. Here, we have two numbers 17 and 26. Then 17 will be divided by 2 and 26 will be multiplied by 2. As we can see, the result of the division is float, so here we will ignore the decimal and talk the floor. After that we will walk through this process until the result of the division becomes 1. Now, for each odd value resulting from the division we will take the corresponding value which was multiplied. Moreover, we will add the multiplied values. Result is 442. Let's analyze the code with the provided numbers, 12 and 6. We set n to 12 and m to 6. Initially, the result is set to 0. We'll now go through the code execution step by step. We enter the while loop and check its condition. Since n is not equal to 1, we proceed. We then enter the if statement and evaluate its condition. In this case, the remainder of n divided by 2 is not equal to 1, so we skip the if statement. We proceed to divide n by 2 and multiply m by 2. We repeat this process until the value of n becomes 1. At the end of the code execution, the result is updated by adding m to it, which is currently 72. And this is the recursive implementation. Now we have reached the base case. Finally we will add them and get the result. Last but not least, let's check the analysis of the code. We will start with this recurrence relation. After we get the first step, we will recognize the pattern until we reach the base case. So, the time complexity is O log n.